Alright, we're gonna be living the high life with acids, and I'm not just talking about any kind of acids. I'm talking about a homologous series of COOH functional group known as the organic acids, otherwise called carboxylic acids. Alright, now all carboxylic acids with its naming convention will have end with the suffix oic acid. For example, if I have one carbon carboxylic acid group, as noted by the C here, where it's bonded with an H, a double bond O, and a separate OH bond, this is known as methanoic acid. Now, methanoic acid also has its own name called formic acid, which is kind of like poisonous acid that insects kind of spurts out to neutralize prey or predators, whatever you want to call it. All right? And what if the carboxylic acid has two carbon atoms, while what you get is ethanoic acid? Now, ethanoic acid is a very common household kind of acid. You can find lots of ethanoic acid in supermarkets in 5% concentration in your vinegar aisle in your grocery stores. So yeah, ethanoic acid is like everywhere. Alright, let's be moving on. And if you have three carbon atoms in your carboxylic acid, it's going to be called propanoic acid. Now, all this hydrocarbon is going to be attached to the C double bond OH group. Okay, this is the functional group. And any chain, as the chain gets longer and the acid groups gets funnier, longer, this C double bond OH should be the main chain of any other long naming conventions. But we'll discuss it more in class and do exercise on that. But let's quickly move on with examples of carboxylic acids. Now, all carboxylic acids are weak acids. So what does that mean? It means that when you put it into solution, it only partially dissociates. So not all of it will dissociate like hydrochloric acid. Only partial parts of it, usually in very small percentages, will dissociate into its respective ions. Okay, first example of a carboxylic acid are the citric acids. Now, citric acids occurs naturally in citrus fruits. That's why it is called citrus acids. All right, this is the street name. We're not going to go down naming this thing because of this triple chain of carboxylic acid functional groups, but it is used as a natural preservative and also put into, it is also a natural antioxidant in medicines. We also put citric acids into antacids, stomach reliever kind of pills. So when you put that into water, you see the fizzing effect is because of the CO2 that is released. Okay, another synthetic type of carboxylic acid is the aspirin, noted by this benzene group, which we never talked about, but we'll maybe talk about it in class. That is attached to the carboxylic group. This looks like a carboxylic acid, but it really isn't. It's like a methyl group contained with a C double bond O and an O and the ground group. This is kind of like an ester, which we will talk later. And finally, another example of a carboxylic acid is an ascorbic acid. All right, it's called, the street name is vitamin C, so you can find that in fruits and also in natural supplements or synthetic supplements, whatever. Okay, so let's move on to examples of reactions. The first series of reactions are basically reactions of carboxylic acids with metals or metal oxides, or it's whatever metal, metal oxides or hydroxides or what have you. Okay, so here we go. These examples are kind of what you're already familiar with, instead by using strong acids reacting with metals. But now, instead of using strong acids, we'll be using weak acids. So, the first example is a carboxylic acid with an elemental metal, and what you get out of it is a metal salt and hydrogen. The example I'm going to use here, and all these examples, are ethanoic acid. So you have 2 moles of ethanoic acid reacting with magnesium, you get your magnesium ethanoate, okay, and hydrogen. Alright, how do you spell ethanoate? It is O-A-T-E, right? 8. So no 8. Alright, ethanoate. Okay, so here we go. Another example is a carboxylic acid with an alkaline, which is a soluble base. Alright? And what you get is a metal salt and water. So this example is ethanoic acid with sodium hydroxide to give you sodium ethanoate and water. Another example is carboxylic acid reacting with an insoluble base or metal oxide to give you a metal salt and water. This example is 2 moles of ethanoic acid with zinc oxide, and that will give us zinc ethanoate and water. And finally, the last example in this metal reactive series is carboxylic acid with a metal carbonate or a metal hydrogen carbonate or bicarbonate. Okay, so I'm going to spell it out here: bicarbonate or hydrogen carbonate. Okay, and what you get out of it is a metal salt, water, and CO2. We know these examples already, and now we're just putting it into perspective of using carboxylic acids as the acid reactant. Alright, so this example I have here is ethanoic acid with sodium bicarbonate, which is baking soda. Mix them together and you get sodium carbonate, water, and CO2. That's it, easy peasy. Now let's move on to talk about examples of reactions of carboxylic acid with other organic stuff, or in this case, not quite organic, but alright, non-metal. Okay. Here we have carboxylic acid reacting with an aqueous ammonia. Now, why aqueous? Because ammonia is a gas, and in order to make this reaction work, you gotta dissolve ammonia in water. And this is exactly what we're doing: carboxylic acid with aqueous ammonia to make an ammonium salt. Alright? This example again is ethanoic acid with aqueous ammonia to make ammonium ethanoate. Alright, and finally, the reaction example is carboxylic acid with an alcohol to make a sweet scenting ester and water. So what we make here is an ethanoic acid with ethanol, and we make the sweet scenting ester with water. Now this naming convention here is that you follow this functional group as your ethanoate, with this functional group here as your ethyl. Alright? So it's ethyl ethanoate. That's it. We'll do more exercises in class. Exercises.